Welcome to this extended episode of Capacity. We have Grady and Adam Zaouague from Reata Machine Works and Engineering. We're going to do more of a Q&A session that we're just going to talk about the future. We're going to talk about where manufacturing is going, where technology is going, where the labor force is going. Welcome, guys. Adam, you are 19, 20 years old.
Yeah.
You work at Reata.
Mm-hmm.
Welcome. We're going to just spend some time talking about the future. We spend a lot of time talking about your journey, but I think the very next step is to kind of explore what we all think about where things are going. So welcome.
Yeah, thank you.
Why don't you control things? What you direct us as to where you want to go. Yeah. Start lobbing some questions around and we'll get started.
I had a question for you. You talk a lot about manufacturing as, SMEs, small and medium-sized, manufacturers and how you want to create a community of those. And we don't want to have a bunch of ASMEs, 5 big manufacturers to go to. From the software side, do you think that there should be, some sort of software connecting a community of manufacturers? And do you think Fulcrum could drive that? Because I know a lot of people have tried. We've had people from associations try and make software to connect different manufacturers and platers and painters. Because there's one person who drives a process or makes the recipe, and you can all kind of. It's better just to send it out to them. That's not our value add. And I've seen people try and make software to kind of bridge those gaps, but it hasn't really worked. We've tried to use it and it hasn't, led to anything. So do you know if there's anything from your perspective that could drive that change? Maybe it's more dinners like yesterday or more events or more, in-person conversation or conventions or things of that sort.
Yeah. Internally, we talk about strategy. We try to make it as simple as possible. And so we try to distill it down to, okay, we have this vision for creating a digital network of manufacturing. What are the things that need to exist in order for that to happen? Mm-hmm. And how do we shrink that as much as possible? I think the dinner last night is an effort for us to show people that this is a non-zero sum system, that everybody doing better can make the entire manufacturing network dramatically bigger. And I think if that belief is even a little bit in the market, it doesn't have to be the majority, just some really great people saying that and just believing that needs to exist. I think it's very close, but there needs to be a little bit more of that. The second is, from a technological standpoint, there needs to be an operating system that's networkable. Mm-hmm. I think our insight that's very humbling and also very encouraging is manufacturing is already a network. It's just analog. It's through fax machines sometimes, unfortunately, but through emails and through phone calls and through site visits. Our job isn't to create the network. And I think when you try to create the network, especially when one already exists, it's really never going to work. Our job is just to digitize it. It's already analog. How can we digitize the network that already exists? And how do we preserve it in the best way? And then the last is, how do we create a product where everybody who uses it has more throughput than people that don't, but also isn't so rigid that it prevents innovation. Like our number one goal is to enable all these smaller manufacturers to continue to add ideas to the network. That's the thesis. 5 big companies are just not going to make as many smaller things, as many lower run things. There's a lot of usefulness that's there, right? And they're also not going to come up with as many ideas. Like the economies that are dominated by big players, centrally planned governments, and maybe countries where they've really had big companies come in before little companies could really even establish, they tend to lose out. And if we can create a piece of software where everybody's ideas can permeate really quickly and they can make enough money where they don't go out of business, they survive. I think if those 3 things happen, this vision for the future will come true for us. So, yeah.
So, kind of an interesting thing we do at Reata is, I think this is a little different from other shops, is we have people on our team, that can program. And, we find certain things, in the back end of your system that we're like, oh, this is really cool. We could definitely use this. How do you feel about, more customization on the ERP side? I feel like a big, hurdle for you guys is you have a bunch of different manufacturers who do it slightly differently, and trying to make a software that kind of covers the full span of that, and make it, make everyone happy. And you can't do that always. We might have, and maybe we need to bend our processes a little bit more to align to the system. But how do you feel about that, customization piece of it? We'll find, different API endpoints. Like, oh, we can make a little software to do this, or a lot of things I'm excited about are adding AI to things that don't have AI. So we'll have different webhooks come out of the system, and we'll make automated reports and those sorts of things. I just think that's interesting, and I don't know, how you guys feel about that.
Well, I do not want you to bend your process to the system. That's a horror that we currently have, but are aggressively moving away from. I do think that sometimes when you're creating new technology, you have to name your enemy a little bit, and shouldn't be a person or a company. But I think the enemy for us right now is a very reasonable enemy, which is just the fact that most other system of record products for manufacturers have a huge amount of services to implement. If you look at the total number of dollars spent in like manufacturing software, something like 85% of it is spent on services, on consultants that are writing custom software. That customization actually makes your system so rigid that new technology can't really get into that software.
And part of the problem is when your software changes, now you need the consultants to come back in to fix everything that's broke.
That's right.
From
Well,
those changes,
there's a symbiosis there, right? That those changes drive more consulting hours. But if you think about the number of dollars being spent on actually building technology versus customizing it, that ratio is just kind of broken. I think it was unavoidable. If you zoom back to the 1980s when ERPs and MRPs were first implemented, there's no other way. You know what I mean? Back then, it was a giant mainframe in a closet with wires to a screen, with floppy disks to upgrade the software. Like the software wasn't really built out. That consultant was essentially building it out for you last mile. And an enormous amount of value is added to the system. But by now, we don't need it anymore. We can develop software a lot faster. There's kids like you that are at a lot of the companies we work with that are able to work on stuff. So we believe that making it open, you'll just be able to play with it and you'll be able to take it that last mile yourself. We also believe that in the product, there's things that are physics-based. You're not going to violate the laws of physics. So if that's the case, if there's some first principle there, then we can build software that's very rigid because we're rigidly defining physics. That's okay. And then the last is, I think, there's some level of configuration, some level of flexibility that's a UI, like an UI interaction. That's just you configuring things that kind of don't affect the flow of data. They're, maybe adding a column to a grid or personalizing something. We want to build those features as well. So for us, that's the strategy. Reduce services, really isolate the physics-bound stuff so that we can rigidly define those, but give you the ability to customize it infinitely in code and give people the ability to personalize it infinitely through the UI.
From your perspective, there's a saying that, if you're really serious about software, you should be really serious about hardware as well. And, where do you feel, because I've dealt with this personally, even with Fulcrum, any ERP is, you have a really great software, but does the hardware complement that as much? And where can you kind of own that? We're in Minneapolis, and I think Target is a great example of, they've built hardware into their services, and, changes in the system aren't really driven by clicks or data entry on the UI. It's more driven by real life action. They'll scan a barcode, it'll automatically, say, okay, this is what you have. You scan something else, automatically adds it, to their cart or whatever. Where do you feel like that plays with on the manufacturing side? Because maybe from your perspective, you don't want to force people into a certain hardware ecosystem or a certain way of thinking. But I think from our perspective, if there was more rigidity there, then I think the software would better talk with the operators and maybe make it a little bit easier to train.
I'm fine with that as long as it's Apple.
In the technology space, we call this tight coupling. So sometimes in software or in hardware, you're tightly coupled to a piece of hardware, or maybe your software is written in a way where these two systems that are essentially subsystems are tightly coupled to each other. But we pillage a lot of concepts from manufacturing. We talk about lean software development. Well, that came from manufacturing. Agile came from manufacturing. All these Kanban things came from manufacturing. I think a lot of software developers don't realize that almost all of our ideas in software development came from manufacturing. But there's some philosophical debate about coupling. And it's, I think, very similar to manufacturers who decide whether they want to like in-house powder coating, or they want to do some sort of anodizing or finishing, or the painting, or maybe they want to do the sheet metal fabrication as well as a CNC, and they want to assemble it through robotic welding together. As you add components to your shop, the complexity of operations goes up non-linearly. And you can develop the power to do that through having more money or having better skill or better people. But I'm very wary of adding too much complexity to my organization. And I think I get that from all the businesses that I saw before I started this company. So I do agree that there is a lot of value in tightly coupling. And I hope that one day, hopefully in the next 2 or 3 years, we have enough money, we have enough customers, we have enough power to operate that. But I think for now, just building a full stack end to end from quoting all the way to invoicing system, I think that's kind of the limit to our power. We want to just do that really well. You can say something?
I totally agree with you there because, everybody that's fully vertically integrated, they end up taking that apart because it's not efficient. And there's people that specialize in this and specialize in that. And I think that's, and especially in the hardware world, talk about something that changes quickly. How are you going to keep up with that? And then if you've created your own and you've got a processor, and we go through a period of time like the last few years, now you can't get processors. So you can't, that's just another whole. But that said, I think a couple of things of what we've talked about here, and you guys already do it a little bit, but I think ultimately, as you get more defined, if you came up with videos of these are the best practices we've seen out there. If you implement your ERP using these best practices, you can choose to or not to. You can do it the same way. But I think that would be a really good tool for all of us to be able to look at and maybe change our mind. And then next is like, okay, all the hardware technology that's out there, how is that going to impact the world? Whether it's tablets because of what they've got, but let's even go a little bit further. Where are the glasses?
Sure.
I mean, the Vision Pro.
We bought some. We're experimenting.
I know, and I have Vision Pro, and I'm like, this is amazing.
It is amazing. Doesn't do very much, but it does it amazing.
I am not in the demographic of that at all. I know, but I'm just going like from a training tool, from a being able to set up tool. That as a tool I see that your software integrating into really well is like, okay, time to set this up. It brings up this. I mean, yeah, you can bring it up on the computer screen, but if somebody, and yeah, they're clumsy at this point, but they'll get a lot better.
Oh, absolutely.
And oh my gosh, how much time is that going to save? And how much is that going to help us drive even more youth into our industry? Because again, it's a cool factor of where do you get to go to do that kind of stuff every day?
Well, imagine being able to operate robotic arms remotely using a vision system, right? Like there's a lot of really cool ideas.
Oh yeah. We've messed with that a little bit with Oculus and Fanuc. You can do that now, just
not well enough.
Not well enough. No, it's not integrated well enough, especially with AI and these vision large language models, being able to maybe see what you're doing and maybe count that as work. There's a lot out there
for sure. No, I think our North Star is kind of hardware agnostic. It's not hardware or not hardware. It's we want to build software and technology in general that helps you produce better. So we actually, very controversially, do not have an accounting system. We integrate with a bunch of accounting systems, but accounting helps you operate your business. But it doesn't really help you make more stuff.
I totally agree with that. I think the days of a accounting system and an ERP, the financial side, they want to be able to do stuff, and there's software that's all they do.
That's right.
And as long as we can talk to that, which we can, that's perfect. I think if you try to make your software be all of everything, it won't be very good at any of it. And that's in anybody that demands to have their accounting in their software now, I think they're just looking at it wrong. I mean,
And the way that I think about it internally is if I imagine having an accounting system team, how much would they work with the rest of the team? And be very little.
Right.
And essentially I'm just running multiple businesses then.
Right.
And then how much benefit do our customers get when they have an embedded accounting system versus not? It's very marginal.
Yeah.
In fact, maybe even negative. But yeah, so like, and then extending that to the technology thing or hardware technology, for me, I'm just trying to train myself to look for when they're becoming robust enough. So for me, the North Star for hardware is vision density. How many pixels of information can you capture and then also encode and transfer per second? And right now, we did it. We tried it. We did this pilot where we had some of our best engineers work for almost a month on being able to put a part in front of a camera to measure it.
Yeah.
And we figured out some clever stuff. Like you don't actually need to measure it. You just need to measure the ratios. Because when you CNC a part, it's very unlikely that every dimension is equally off, right? Usually it's one dimension that's off. And if you just look at the ratios between them, you can say, I don't know what the measurement is, but I know this is wrong. And we got pretty close. But we also determined mathematically that cameras have to get roughly 8 times better. And when they are, when the iPad 21 or whatever it is just has a high density enough camera in the back, every one of our customers will be able to just measure first article, make sure the ratios are correct. Then they need a caliper to measure one dimension in physical space so we know. And then we can calculate all the rest of the ratios automatically. That would be pretty amazing.
That's pretty cool, yeah.
And you don't have to buy any of our hardware. Any tablets that you have that spec on their camera, done. Or there's accelerometers on there now. Sneakily, we can tell when a machine is running or not just by turning on the accelerometer on an iPad. We're experimenting with that.
Vibration is.
That's right.
Yeah.
And so we don't need to know information from the machine. So those are the ways that we really want to develop our product. We want those clever. You already have the hardware. There's no additional cost, and there's so many sensors out on the shop floor already that you're just not using, right?
Yeah.
Let's open the microphone and see. Let's look at the front camera. There's LLMs that can tell us if someone's focused on the work or not, or if they're focused on reading the drawing, and then we can match that with what's going on the tablet. So there's a lot of stuff that we're experimenting with. But I would say that without giving too much away, most of the hardware is just a little bit behind. The Oculus Fanuc is just a little bit too clumsy.
Yeah.
But I think over the next 2 or 3 years, once those things become unlocked, we're going to be racing to implement them.
I agree. I mean, I think it's, again, if you don't want to be part of it, you watch out because it's going to be all consuming.
And again, I don't think it's going to get rid of jobs. It's going to make humans not have to do the tedious part of the job to do the interesting part of the job.
And it's going to just make them more efficient to be able to get through stuff much quicker. And it's going to do all the hard, sometimes when we go to research a part that we've run multiple times, it takes a human a while to punch through, click everything, look at all that data. Whereas ultimately that can be an AI script of like, and here's all your data. I mean, I'm guessing you're doing that in Tableau now. When the data you get out of Fulcrum, you're able to pull so much of that out. And it's just loving that we can look at things through these different lenses to get the information we need. Because at the end of the day, what you guys enable us is this library of data, and then we get to use this data to really help us know where our problems are, what we need to work on, and what we need to fix. And
yeah, I think we started dipping our toes a little bit into machine learning and those sorts of things. We partnered with MSU Denver over university down there, and they got a really big AI grant to build AI in manufacturing. So having all this data, with our machine monitoring and with Fulcrum, you can make really good inferences on what's going on the shop floor. And I, honestly, I spoke to another tech CEO in the manufacturing space, and I told him, I was like, I want to use manufacturing. I want to use AI in manufacturing to drive, insights and those sorts of things. And he told me, he's like, you can't do it yet. I'm like, why not? He's like, well, you don't have a time series, AI, or time series transformer. And I told him, I was like, well, watch this. And It's kind of cool, having, with Fulcrum and with our machine monitoring software, the ability to pull these little pieces of data, and kind of interesting, those logs that you provide, in each job, those you can use with an LLM to quickly dissect what's going on.
Yeah, I think those logs annoy people. They're like, just tell me what happened. But really what we're really moving towards is a fully functional, completely comprehensive event stream system for manufacturing, whether that's machine data or human data or video data or inferred data. That is the future.
We're working towards big data, and we have all the data available to us. We just need to be able to capture it and have tools easy enough to have it explain what we either confirm what we believe is happening or tell us, no, you need to look over here. And that is where people like Adam and Adam's age are going to transform manufacturing into what I think will be the most robust and fastest growing part that we've ever seen because of what they're able to do.
I would disagree with that other tech CEO. I would say that what we've discovered with transformers and LLMs is essentially exactly what we need. If you have a time series of all of your punch-ins and punch-outs and events, what GPT is doing right now is predicting next word. What you'd be doing is predicting next event. I'm going to predict the next series of events. Am I going to make money? Am I going to make money? Am I going to have enough cash? Am I going to have the amount of materials? You can start to predict the future, essentially. And you're not really predicting the future. You're just measuring the inertia of the data you already have. Underneath, there's some seismic data that you just can't see. He might have some intuition. You might just look around the shop and look at your numbers, and you have an intuition. There's some stuff changing, but we can see that in the data as well.
Well, that's where things. So if I can eliminate anything before I'm gone, is I don't want to be. I always say I don't want to be the guy. I don't want to be the historian. I don't want everything dependent on me, and that I think is where AI it removes me. Now there may be some people that want to be that guy, but I don't, because it'll be much more efficient for everybody else to be able to use some form of software to get the prediction that I probably would have given. I mean, at some point, mine is based on intuition. It's based on the data I've seen, but it's also got a lot of bias built in there that the AI may not have. They may, we'll be able to remove some of that bias. And so it might be a different answer than me, but it might be the correct answer too.
Well, I can make a Grady GPT and then have your bias.
but yeah, we can, but that's ultimately not where we want to be. We want to remove as much bias of the data. And like in my, I quoted that job. It should be running at this time, but it's taking this long. Well, at some point, the reality is you quoted it wrong. so you need to, and that gets into like even the estimated times. Once your system starts looking at, this part with these kind of features takes this long, we've looked at everything and that's about the right time. And you quoted this part, well, you probably need to change the quote on this part based on all the history we have on parts similar or that have similar features. And that's where we're going. I mean,
yeah, that's why we're so focused on actuals. We want every one of our customers just to have as clean of actuals as possible. Because that relation between what it actually took, that variability, and the geometry of the part, that's really where the magic is.
Oh, yeah.
And I think a lot of shops don't understand that they're either selling consistency or they're selling variability. If you're a short run manufacturer, what you're saying is, I don't know how to make this, but there's enough margin in here and I'm good enough that I can figure it out better than other people. And sometimes those shops overstuff their schedule and they don't understand that they're actually selling variability. And then they try to operate their shop with some OEE that's like 99% uptime. And then one thing goes wrong, because it will, because they're a short run shop. And then all of a sudden everything cascades to failure. So the actuals essentially help you estimate the variability of a part geometry. And I think that's something that people don't really talk about, that we really think could develop a lot of value for people.
No, that's absolutely removing that bias there, and that's what has to happen.
So it's kind of digitizing all of that, engineering knowledge of, lean manufacturing and all of these things, and making it easy for everyone?
Yeah. We talk internally about automating as much as we can, especially tedious work. We really try not to automate advanced work. The scheduler is kind of automating advanced work, so is purchasing, but the majority of the automation is tedious work. The second is visibility, just showing you as much as possible so you can react in real space. But the last is actually allowing for more complex things to be solved. So the reason why one-piece flow is so powerful is because humans are too dumb to solve these really complex problems. But with computers where they are now, I think there's a whole world of problems that actually can be solved.
Yeah.
And you can just say, do this here. Right.
Well, and I think that's where the scheduling piece comes in, is ultimately we can't do that many iterations in our head.
That's right.
To know which way, yeah, somebody in the shop can go out there and magically do that, but they can't forever, and they can't do it. It's not expandable. I mean, it's not scalable at all. Mm-hmm. But if you put enough math to that and then some AI into the scheduling, that is solving as big a problem for job shops, because we have to change. So we have to be able to do what ifs all the time, because especially for a customer service organization, I have to, if that customer wants this part a week sooner, I have to figure out how to give them that part a week sooner and what impact it's going to do on everything else. Mm-hmm. I mean, I can do it now, and I call it, Grady goes out there and it makes this huge tsunami wave that we're a hero to this customer, but we just crushed 3 others.
That's right.
And now we have to go out and perform a miracle after miracle after miracle.
And overbuy inventory.
Right. And it would be nice to know, like, okay, if I do this, this is what's going to happen. But if I change these 2 things around, this is going to make it that much better. Mm-hmm. So I think that's a huge place that's going to help job shops. And then ultimately our CAM systems being able to, they already make some decisions for you, but ultimately make a lot of decisions on the best way to produce a part, because I think ultimately the computer will be better than an individual programmer on that. Not to do away with programmers, you wouldn't, but it would give them the tools and technology to advance that quicker.
Like everything else, it would allow them to program more.
Right. Right. Because that's where we are, right? I mean, if you said, Grady, what's your biggest bottleneck to getting something out the door quickly, a prototype, it takes longer to program it than anything else.
That's right.
And it's not because my programmers are slow. It's just they have to create it.
And there's a lot of stuff that we want to work on that we just can't until things change politically. A lot of these machine manufacturers still believe that there's a zero-sum system. Like, if you're not going to buy this machine, you're going to buy another one, and they want everything in a closed system. But I think that's changing really quickly. And I think it'd be really cool to be able to send a drawing right to the machine, associate that with the outcomes, pull it back, tell you what this looks like, so that when you program the next one, the CAM program cycles don't have to be repeated. We just look at the variance at the very end. There's like a lot of efficiencies I think we squeezed out.
And I totally agree. The machine builders, and some of them are, and
some of them are.
And more of them will over time. And
That's right.
Sometimes it's not even the machine builders; it's the control system people that are selling the controls. Are the ones that want to close it all down, and they don't even offer.
That's right.
The ability to do what somebody else has, and they.
Well, it's the same service versus ERP thing we were talking about before, right? Some of these control system services dominate the dollars that you spend on something like that.
Yeah, and so they'll have to be changed there, and they'll be changed there, because if they stay that way, newcomers will come in and replace and take over.
Yeah, I was just in Japan and talked to the folks at Amada, and they're like, "We are bad at software. We're going to give up once we can find somebody else that can help us with this." Mm-hmm. So I think it's already changing.
So every time we delve into either a Fanuc or a Mitsubishi manual and controls, because our logic's different. Mm-hmm. We don't think about software the same way they do. And it's really hard to transform yourself around that. That's right. And, that will hopefully change over time to where there's these common languages that we can apply our logic to and
that's right.
and transform it.
But, just like something simple as like, why would you want the next operation to start before this is fully complete? Well, because I want to, have a continuous flow throughout things.
Oh, no,
that's like a very foreign concept in Japan,
And that's really interesting, because, that's all we do.
And you squeeze a lot of productivity out because of it. So.
Right. Or why would you want to ship a partial before you're finished with the whole job?
That's right.
Well, because our customer needs that to keep their line going.
And we get cash faster too.
And so those are things that I think, and there's a lot of shops that are like, no, so because I have palletized systems so much, I would rather a customer say, instead of I need 300 parts this month, I need 30 pieces per month. I'll give you the 300 piece price, but I want to only run 30 because I want to get 10 more of your other parts that you only need 30 a month of to run as well.
Right.
So I can get diverse or other customers in there to run so my machine's not dominated by that. So I can have that diversity of parts and you get your price, but the machine's always set up. So I really don't have to 100% set up. I have to inspect, but I don't have to 100% set up. But I'm willing to do that for more part diversification.
Going back to an earlier point, what you just touched on, the reason we have scale, like the Gigafactory for Tesla, is because we don't have the logistical coordination and nimbleness to figure it out with this network of manufacturers. I really think that once that, philosophy of diversification and nimbleness sets in and permeates the entire network, you won't ever need a hugely scaled up factory to do one thing. Because then a company like Tesla could iterate on their battery much faster. They could change one component. Maybe it's a different set of vendors. But once you connect all this stuff together, that's when a lot of the magic's going to come out.
I agree. And I think, some of the people behind the one shop does it all. It does, but it does it all poorly.
That's right. And requires a ton of capital.
And people want customization.
That's right.
They want to get to that point where I want a bike with these features in this color.
That's right. I think medium run to short run is the future.
Yeah, well, especially for us. I mean, the long mass produced stuff is probably going to reside somewhere else, and that's okay. Yeah. That's fine. I'd much rather be doing the entertaining stuff. I mean, at Reata, we want the parts that keep you up at night. We want your hardest parts. We don't. If you give us a square part that needs 4 holes in it, we'll screw that up. And I always laugh because it's true. We're always told, well, you were too expensive on the easy part, but you're way cheaper on the hard part. And I say, well, that's probably a mistake, but that's why we got good at hard parts. And I think that's our motto is I don't really want the easy, boring parts. Give us the hard, complex parts, and we'll figure it out. Now, my programmers and machinists sometimes go, why do you do that? Entertainment.
Yeah, that's right. Well, and they're the ones that allow you to have that entertainment, right?
Yeah. Right. Well, it keeps them. I mean, if I just gave them a square part with 4 holes in it, they'd be like
pretty bored.
Yeah. Challenges.
Yeah. I always see you try and push a lot of hard parts onto people. I remember I always peek at different quotes going through the door, and we've had some really hard parts go through, and I'll bring it up to our programmer like, hey, did you see this part come through for quote? And he's like, no, I don't want to do that. I'm like, I think it'll be pretty fun. And then I see you always push him like, oh, you could definitely do that part. And he's like, no, I don't want to do that part. I can't do that part. And you push it through anyways. And then he ends up actually making it happen, and it's beautiful. And I'm like, well, there you go. And I think bringing up that confidence within other people is a cool thing.
So you have to sell inside your own company sometimes. And I go back, I don't just say, well, we have to run it. I say, well, what if we did this? What if we ran it like this? And come up with ideas. And then all of a sudden go, oh yeah, I guess we could do that. And it's like, we can do this. And, I approach it from a sales standpoint, but I'm also approaching it from a if we learn how to do this, this opens up a whole toolbox of other things we can do. And more times than not, it's a problem a customer has, and I told them we could solve all their problems, so let's figure out a way to solve it.
Yeah.
Now, if somebody sends us a sheet metal part and it's not what we do, and we'd have to farm the whole thing out, I tell the customer we can quote it, but we're not going to add any value to it. So if you really want us to do it, it's probably better to have somebody that adds value to it.
Yeah. So you've been asking questions instead of answering them. How you are learning how to make recipes, and you're also executing them now. You're applying new techniques that maybe don't exist in the company, but how does it feel for you? What's your perspective on Reata, on manufacturing, on learning this from the ground up?
So I think at Reata, I've kind of made a name for being the ideas guy. I think I come up with a lot of different ideas, and a really hard thing for me has been kind of balancing, those ideas with actual execution. I only have so much time, and I think it's been really exciting. I think me kind of going to Reata was kind of a perfect situation. Because, I think, people like Grady and other people, management level at Reata are really open to, new technology. So even though I bring up, crazy ideas, they're crazy enough to take them on. And then we see that output. So, for me, I see that all, the technology is really there. A lot of people say, I can't do this. It's not there yet. But from my own personal experience, maybe coming from a different background, the technology is really there, and we can make it happen. I think I always tell them, if there's something you think you can't do, we can definitely do it. Either I or someone else can make it happen, and the technology is already there. And it's sometimes a little frustrating to me, like, we're not using this technology. Well, let's get it in there, or let's have someone do it. And I think it's balancing all of that. And I think, I have a vision, for how I want to see things. Grady has a vision, and it's kind of, I think it's kind of exciting, seeing that kind of come into fruition, especially with all the different technologies out there. It's so exciting. And I think it's the reason I'm in it. I wanted to be an aerospace engineer instead of being in manufacturing. But once I felt I feel like manufacturing, especially in our scale, has the most room to grow and the most room to optimize. So it's just finding little pieces to make that happen. And it's like playing a big tycoon game, but in real life, which is kind of cool.
Mm-hmm. Has it felt like that? You've been playing a big tycoon game for the last 30 years.
I'm sure that's probably a real game that I don't know about, which is so. I really enjoy. So I'm an engineer, but I'm the baby boomer engineer, and all the other engineers are Gen Z. So there's a huge gap there. But I think that gap, it has to be filled in, and they fill it in to make it. And I guess I'm enough of a geek that I either know about it or will learn about it, and I'm pretty interested in trying it. And so, some of the other managers might not be interested in it, but that's the only way we're going to move forward, is try different things to see what will give us the better performance. And most cases it works out perfect, or we have to, maybe we have to step back and change our direction. But I see some of the things that we're going to be doing with automation and software as, things that might ultimately become products to help other companies
for sure
do what they need to do with some of the automation ideas that these guys have. And
you'll be able to distribute those ideas much easier now than before. You know what I mean? Right. You won't have to fly out there to implement. Right. You can just send them some code.
And so we took on an aerospace job that requires us to test a high pressure cylinder at 12,500 PSI. Everybody's like, oh, Grady, we've got to farm that out. It's like, no. I mean, they wanted like $20,000 to farm that out. I'm like, no, these engineers can figure this out. And it was a project. And oh my gosh, there were catastrophes along the way. But I kept saying, are you learning? Are you learning? And the engineers that were involved were like, yeah, but man, we're going to have to remake these parts. I'm like, it's fine. As long as you're learning, the parts are going to repeat. We're going to be fine. Well, we figured it all out. I mean, we went to the customer at one point and said, boy, these things are failing left and right. Are we doing something wrong? And they said, well, the bad news is we have no idea how they were tested. And they're parts from 1973. Mm-hmm. So I'm like, well, they've been tested since 1973. So, well, we figured out our technology that we had done. And so we made our iterations, and now it's like, oh, that's easy to test. We'll be able to do this throughout the future. Mm-hmm. And it's all about those iterations using technology. And I mean, we were capturing data. The customer had never seen data captured the way we captured it on these. And so they got an upgrade in their testing, mm-hmm. And we're just happy, and we learned along the way. And that's the fun of manufacturing, is all the things that you see Apple or Google or Samsung make and their hardware products, all those iterations. Yeah, an engineer maybe at Apple came up with the idea, but it was manufacturing that developed all the techniques and all the tools to be able to really do it. And
sure.
they did all the iterations. So without manufacturing, they couldn't have got.
Well, I think your hope for your legacy and this generational value you've built in Reata, I think with people like Adam, it'll absolutely come true.
I think so.
And I think, like you said, a lot of these companies are more held back by manufacturing than ever before. And every ounce of work you do will enable more cool stuff to be built. So thank you for sharing your perspective and talking with me.
Thank you.
Thank you. It was fun.